Thank you. So I thought we should have a tutorial instead of us moving forward. I thought we should solve some questions. So these power series questions I am asked in the exam. So thought that maybe we shouldn't rush. And I've noticed some people have started already submitting the assignment, which is a good thing. But then again, there are those who might be having a bit of challenges. So I thought we shouldn't leave those behind. So these questions come a lot in the exam, and they usually carry a lot of marks. So just to talk about the exam a bit. So exam, so usually you have question 1, which has usually 3 parts: A, B, and C. So part A is specifically for this, what we've done. So it's power series method. Part B is usually Euler equations. Part C is what we call systems or first order ODEs. So this is usually how question 1 looks like. So this is 20 marks out of 100. Question 1. 4 questions usually carry 20 marks. You have to answer 5. And power series method usually carries 12 marks of the 20 marks. So it's usually 12. This is usually 4 because there isn't much to do. And this is usually 4. Sometimes they can change, but I'm just giving you an idea. So it's important that you're comfortable with this method, the power series method, because it's involving and hence carries a good number of marks. So I'll pick out 2 questions from the tutorial sheet and see if we can solve those together. So do we have any questions on what I've just said about this, the exam questions? Is this clear?
Yes, clear.
So the next topic is Euler equations, then systems. So I'm sure there are those who have already done with power series, they are comfortable, they want to study ahead. Just check the notes which are uploaded on Moodle, last year's notes, if you want to study ahead. But I'll be uploading new notes for this academic year. So if you want to study ahead, you want to solve some questions, there are some notes from last year on the Moodle Math 3110 page. So I was looking at the questions from the tutorial sheet, and I was obviously avoiding the ones which are in the assignment, but I picked out this one. So this is question 4F. Question 4F, which is 1 minus x in brackets y double prime minus y is equal to x. So I picked out this one. I thought it is interesting, so we can solve it together. So can we go ahead? Okay, so we go direct. So this is 1 plus x. What is y double prime? We are familiar with y double prime. It looks like, so it is n is equal to 2 up to infinity of n minus 1, n, then a subscript n, then x to the n minus 2. So that's if y is a power series of the form y is equal to summation a n x to the n, then this is y double prime. So this is minus the y, which is n starting from 0 to infinity, a n x to the n, and then is equal to x. So notice that the difference with all the equations we've done is the right-hand side, or should we say in proper language, this is a non-homogeneous equation. Non-homogeneous second-order differential equation, because the right-hand side is not 0, it is x. Okay. So can open the brackets so that we have, so this becomes summation n is equal to 2 up to infinity, n minus 1, n x to the n minus 2, plus summation so it's summation n is equal to 2 infinity n minus 1 n. So now I'm multiplying this x by this series. So this is x to the n minus 2. So this will become x to the n minus 1. Then this remains the same. So it's minus 0 n x to the n. And the right hand side is equal to x. Are we together?
Yes.
Someone is saying they can't see the screen. What do the others say? Are you able to see what I'm writing?
So like the way it works, when anyone else is speaking, because you're not the host, like it would go to the person who's actually speaking, and so their screen will be off, and the person who's speaking will be on. So that's why people are not probably seeing the screen.
Oh, okay. So what we can do is whenever you want to say something, if you're not saying something, you have your mic off. Then whenever you want to say something, you can just switch it on. So you can move on. What's the next step? What do we do? Let's do this. Okay.
I'd like to tell you a little bit about
Sir, excuse?
Yes.
Yeah, I'm a little bit behind on step 2.
Okay. What's the problem? Where is the problem?
I think I didn't understand last time, sir. So everything about step 2 is confusing.
It's better you ask a specific question so that I know what to explain. So maybe if you haven't understood the notes, it's better you go back and read a bit on the notes, then you might be able to understand. Otherwise, I won't know what to explain.
Yes, sir. So
Yes.
step 2,
Yes.
step 2, what you're basically doing, you're multiplying y double prime with what's in the bracket, 1 plus x.
Yes. Yes. So 1 times y double prime, which is this series, gives us this series back. So it's this series is this same one. Then x by y double prime gives us this. So notice that what has changed is that the exponent there is n minus 1 instead of n minus 2. Then everything else remains the same. Okay, so we can move on, I think. So if that is okay, then the next step now is to, so we usually want to write, I want to combine these things right under one summation. The only tricky part is that the exponents have to be the same and your indexing also have to be the same. the first thing to do when you reach this stage is to write everything under one, or try to write your exponents so that you have x to the n. That's usually the first rule. So here the exponent is n minus 2. We can write this so that we have x to the n. We can do the same for this one. Yes. So the first one, this series, so it will be summation. So I want to write this under the exponent of n. So what I'm doing is, on this part, it's like I'm reducing by 2. If I reduce here by 2, I must add by 2 on my indexing. Is that correct? No. The correct thing is I want to increase here by 2 because this is n minus 2. So plus 2 becomes n. So I'm increasing by 2, meaning I'm reducing by 2 here on the indexing. So this is going to be, so that's just the rule. If that is not clear, you can just write it out. Say you introduce another index, let's say m and the like. So this is going to become n is equal to 0 up to infinity. So I've reduced by 2. Here I increase by 2. So this is n minus 1 plus 2, and get n plus 1. This plus 2, n plus 2. And this is n plus 2, then x to the n. So this power series I've written here exactly the same as this one. We just change the indexing so that our exponent should be x to the n. The second one, this one, so it's summation sign again. So again, the rule is I want to increase, this is n minus 1. I want to increase by 1 so that I have n, meaning I'll reduce here by 1. So I'm increasing this side, I'm reducing by 1. So my indexing will be x from n to 1 up to infinity. So I'm increasing by 1. So this is n, then n plus 1, then a to the n plus 1. Then this will be x to the n. Okay. Any questions on this? Is this confusing?
No, sir.
Okay, the last part still has x to the n, so I just write it as it is. So it's n to the 0, and x to the n is equal to x. Okay, so this is the third step. Done with the second step. We've achieved what we wanted. The exponents are the same, and so what remains is to deal with the indexing. So to deal with the indexing, it's simple. Since they've already done the exponents at the same, you just write the first two terms so that your indexing starts from, if you want, from 1 or from 2 and so on. In this case, we want our indexing to start from n is equal to 1 for all these series. So we just write out, this one, we'll just write out the first term, then write the series. So if you write out the first term for this, when n is equal to 0, what do you have? So in place of n, I put 0 here, I have 1, here I have 2, so it's 2. Here I have a2, x to the 0 is 1. So this is my first term, and then the other terms in this condensed form is n is equal to 1 up to infinity, n plus 1, n plus 2, n plus 2, x to the n. Okay, so that's the first one. So I just want to change this indexing to start from n is equal to 1. So just write out the first term. This should not be confusing. Second term is still n is equal to 1. So I just write out the way it is. So it's n is equal to 1, infinity, n plus 1, n plus 1, then x to the n. The last one is starting from n is equal to 0. I write out the first term. So the first term is when n is equal to 0, and that is a naught. A naught. Oh, and this is minus. So this is minus and minus. So this is summation. N is equal to 1 up to infinity of an x to the n is equal to x. Okay, so now we can put everything together. So putting this together, what do we get? So your constant terms are these ones. So it's 2a2 minus a naught. Constant terms, the others we can condense. So it is plus summation n is equal to 1 up to infinity. Then
So
we can
just a bit,
factorize.
show me the first page on top there.
The first,
I can't see what's
one?
on top. The network was tripping. Yes, yes.
Okay. Are you done?
Yes, sir.
Okay, mute your mic. So putting everything together now. So we've put it together the constant terms, then this we factorize. So you have n plus 1, n plus 2 of a, n plus 2. Then you have plus n. So you have plus n, then n plus 1, a, n plus 1, then minus an. Then everything under the x, under the 2 together is x to the n, and everything is equal to x. Okay. So we have put everything together. So we are equating what we have on the right-hand side with what we have on the left-hand side. So on the right-hand side, the constant is 0. So it means that 2a2 minus a naught is equal to 0. Making a2 the subject, we find that a2 is equal to a naught over 2. So that's the first thing. Then
So the constant is equal to 0.
The constant? Yes, the constant is equal to 0, yes.
So y is equal to 0.
You're not equating it to x.
Why are we equating
No.
that? Not equal to x?
No, not equal to x, equal to 0.
Okay.
So we're equating the coefficients. So for 2 power series be the same, the coefficients have to be the same. So we're equating the coefficients. We're not equating the variable. So look at x first. So if I haven't answered your question, then let me do this, then you see how it becomes. So you have this expression. So I'll say when n is equal to 1, before I even write it out, when n is equal to 1, So what does this become? So here it becomes 2. So it's 2 in brackets. Here it's 3. So this is 3. Then here it's 3. So it's A3. Then plus. There it is 1. Here it's 2. So it's 2. Then it's A2 minus A1 because n is equal to 1. Who can give it a try?
2x.
1.
Not to
When
x,
divided
but
by
to
1.
1. Yes. Because the coefficient here of x is 1. So we're equating the coefficients. So here when n is equal to 1, yeah, here you have this will be x and this will be its coefficient. On the right hand side, the coefficient is 1. So that's why we're equating it to 1. And so when you have this, then you're going to have that A3 is equal to, we can take everything the other side. So how does this become? Becomes
Sir, I'm kind of behind where we got the 1. Where has the 1 come from?
good question. Over 2, 3. Okay, so to answer your question, yeah, so what we're equating are the coefficients. So this 1 is the coefficient of x. So let me write on another paper. The reason in here is that if you have two series, say n is equal to 0 up to infinity of x to the n is equal to summation n is equal to 0 up to infinity dn x to the n. So x is a variable. So for these two series to be the same, then your coefficients have to be the same. So this implies that a0 should be equal to b0, a1 should be equal to b1, and so on. So this is exactly what we're doing here. This is exactly what we're doing here. We're equating what we have here with what we have on the right hand side. So the constant, what we have on the right hand side, the constant on the right hand side is 0. So this we equate it to 0. The coefficient of x on the right hand side is 1. So it's the one we're equating with this, which is also a coefficient of x on the left hand side. Remember, x is a variable here. Did I explain?
Sir, repeat again.
So we're just equating the coefficients. So what's the coefficient of x on the left-hand side? It is this. I've just written it out. The coefficient of x on the left-hand side is this. What's the coefficient of x on the right-hand side? It is 1. So that's why I'm getting it to 1. When your right-hand side is 0, then the coefficients on your right-hand side are all 0. That's why we just equate everything to 0. Now, in this case, our OD is not homogeneous. It has got this. We have to take this into account.
So,
does it?
So if it was just a constant and like a variable, if it, for example, it was just any number, go for
Yes.
it, or
Yes. So if it was example, if it was instead of x here, you had say 1. What were you going to do? You're going to equate this to 1. You're going to say 2a2 minus a0 is equal to 1. Because the constant on your right hand side is 1. Constant on your left hand side is this. So it's this you're equating to 1 and not to 0.
Yes, so on that part, I've gotten your explanation. Now,
Okay.
kind of a bit behind on how the X came the other side because my network kind of tripped. Can you just show me the previous pages? I'll be fine.
How this X came on the right hand side?
Yes,
Is
sir.
that your
If you
question?
can just show me the previous pages, I'll be fine.
Okay. So this is the previous one. Are you okay now?
Just on the last step, sir.
The last what?
On the last step, where you have a naught minus summation from infinity beginning from 1 an x to the power n
Yes.
is equals to x. Just there, sir. All the
Yes.
steps on the
So
top up to that
I want
point.
to write this indexing. So this is the last series. I want its indexing to start from n is equal to 1, because I want everything to be uniform. The indexing. So what do? I just write out the first term. So what's the first term of this series? It is a naught. So I just write it out. The rest are in this condensed form. So that's why I'm starting from n is equal to 1 instead of n is equal to 0.
It's okay.
You must have seen this trick before. And the same thing we've done here is what we did for the first one, for the first series.
Yeah, isn't there supposed to be an n on the first series?
Where?
The first series.
No, because we shifted the indexing. So where is the first page? So this is the first page. So you have, so after expanding, you get this. So there's an n, yes, as part of the coefficient, but because we shifted the indexing so that we start from n is equal to 0, this n changes to n plus 2. So you get this. You get this.
And then on the second part, why did it change from n is equal to n is equal to 1? Like after the very same thing you're from explaining, like it changed from n is equal to 2 to n is equal to 1. Instead of having to go to n is equal.
For which one?
For the very first one, the one that was broken into 2, like there's one that we converted from n is equal to 2 to n is equal to 0.
Yes.
And then the other one, which was n is equal to 2, but we dropped it down to n is equal to 1 after decreasing the, I don't know.
So the first series looked like this. So it was like this. So this is the first part. So the idea here was to have x. In all these series, we wanted the x to have exponent n, uniform exponent. So we chose n. So we want everything to look like this, x to the n. So what we do, shift the indexing. When you shift the indexing, we get this. So you have your x to the n. You have achieved what you want. All your series have x to the n. So this is x to the n, x to the n, x to the n. Then you want to achieve now uniform indexing. So what we do now is just write out the first terms. So so just write this out. Write out this for the first one and write out this for the last one. So that all your n start from n is equal to 1, n is equal to 1. The other thing you would have done.
Okay, my question was with regards to the n is equal to 2 at first. After letting something n being equal to n minus 2, we drop it down and all that we convert it to n is equal to 0. When we try to achieve the n is equal to 1, we start substituting. But what about the second part? Like after saying we say let n is equal to n minus 1 so that we can actually convert everything else. Why do we have to we have to remain it having only 1 instead of having take it to 0 as well, since the first one also was like taken to 0?
I see your point. So what is happening here for the second one? The idea is not to bring the indexing to 0 for everything. The idea is, so let me just put this here. So we are on the second series, this one, yeah. So the first thing we have to do before we even do with the indexing, we want this to be x to the n. So it's the exponent we're dealing with. So ideally, what you want to do is maybe introduce another, let us say m is equal to n minus 1. So when you do that, it means if you start your summation here for the m, since n is starting at 2, m is going to start from 1.